Good morning. This activity is M3-A1. This activity is on the modeling of 3D building structures. So demo problem: construct the structural frame of the concrete elements of the two-story building using the following data. We have here the data for strength of concrete, 21 megapascals, Fy 275 megapascals. We have the thickness of slab, S1 is 125 mm, S2 is 125 mm. We have the column sizes, C1 is 300 by 300, C2 350 by 350, C3 is 400 by 400. For the loads, we are given superimposed dead load 0.5 kilopascals, live load 1.9 kilopascals. This is for classroom. This is also found in the National Structural Code of the Philippines. And live load for corridors, still found in the NSCP, we have 3.8 kilopascals. The roof dead load is 1 kilopascal and roof live load is 0.5 kilopascals. This is the 3D rendition of the structure as a two-story school building. We have the details for beams. We have footing tie beams, TG1, TG2, and TG3. On the roof level, we also have RG1 and RG2. On the second floor level, we have this set of beams. We have G1 until G7 and B1, B2, and then CB. CB meaning cantilever beam. These are the details. We have front elevation, the height of the structure from the natural grade line or from the finished floor line up to the top of the roof beam is 6.4, and the distance from floor to floor is 3.2. This is the foundation plan. Here is your C1. Your C2 is in the middle, somewhere in the middle, and then C3 is on the other side. This is the detail of the second floor. You can see the slab S1. Inside the classroom is S1, and then on the corridor is S2. And then we are given the location of the beams as stated in the schedule. Then on the roof level, we are given the layout of the trusses as well as the details of purlins and the turnbuckles or the cross bracings. Alright, so let's open frame CE and start modeling the structure. Open frame CE. Then go to Files, New Project, and then choose this template. In this template, this is a template for drawing 3D buildings, wherein you have the value of D, which is the distance of the column in terms of its span distance, B is in terms of its bay distance, and H is in terms of the height of floor to floor distance. So here we can see 4.5 as distance between columns in terms of B. So let's count 1, 2, 3, 4, 5, 6, and then we have a 4.7 here. So for B, let's have 4.5, 5 times 4, 5, 1, 2, 3, 4, 5, 6 times 1, 2, 3, 4, 5, 6 times, and then 4.7. For the story height, as I said earlier, the floor to floor distance is 3.2 meters, but some engineers would like to model it to include the height which is below the ground level. Now, let's just make an assumption as of the moment because we don't have the details of the depth of footing. So I will assume it to be 1.5. So the first height is 1.5. No. Yeah, 1.5, and then 3.2, then 3.2. And then for D, we have here 7 and 2.5. So 7, then 2.5. Then fixed, then click add, then click OK. At the moment, just press OK or exit. So this is now the stick figure of your model. Next is we input now the material specifications and the sizes. So let's go to materials, then add, then click user defined, then click concrete properties, and then let's go back to our given. The given properties is FC prime 21 megapascal, FY 275. 21 and 275. Now, stiffness modifier, we are trying to design the beam, the structure to have a strong column and weak beam to allow a little flexibility. So with that, we are going to change the stiffness of the beam. The beam will have a stiffness of 0.35 and the column will have a stiffness of 0.7. Now that is a factor multiplied to the actual stiffness of the section, just to allow a behavior which would allow to sort of have some flexibility in the structure in terms of its seismic reaction. So press OK and then click this icon so that you will be able to input the dimensions of the width and the depth of the columns. So for the columns, C1 is 300 by 300. So 300 by 300. Press OK. Then add. Then C2 is 350 by 350. Then C3 is 400 by 400. Okay. So what I will do here is select the columns where I will assign these sections that we have earlier defined. Alright, so to select it, now we have a lot of tools here. We have a lot of tools to pan, to rotate, and to view the structure so that we can clearly select the member where we will place the properties. For example, this one, we can use this command to orient our structure in this manner, because in this manner I will be able to select as many columns as possible having the same properties. Now let's look at the beams. These are the beams that we have, and these are the dimensions. Most of the beams are 250 by 400, and we just have a G5 which is 250 by 500, as well as G7. So with that, we will only model 3 beams for the second floor, or 2 beams rather, 250 by 400 and 250 by 500. Yeah, we still have this B2 which is 200 by 400. So 3 beams, not 250 by 400, 250 by 500, and 200 by 400. So let's create materials again. Add. We have 250 by 400. Okay. Then add 250 by 500. Then 200 by 400. Alright. So here we have G7. This is 250 by 500. We have here G5. This is another 250 by 500. We have G3. This is 250 by 400. And we have B1 in the middle. This is an intermediate beam, and the dimension is still 250 by 400. We have G2, 250 by 400. G6, this is still 250 by 400. So let's try to remember that one as we assign the properties of materials in frame CE. I'm going to activate the second level. I'm going to rotate the view so that I can select as many G7s and G5s as possible. So here we have G7 and G5, and that is 250 by 500. Okay, and here this is 250 by 400. Right click, edit beam properties, 250 by 400, apply. Going back to the figure, we have here B1 at the middle, and we have not drawn these beams yet. Alright, so we will draw them separately.